right, guys, we are going to add to our notebook yet again. We are getting to the end. Hey, that kind of rhymes. So we'll do page 120 and 121. And I know this seems like it's the last one, but there's actually kind of two more after that. So we'll have to add some boxes, but that's okay. So we're going to talk today about solving quadratics in standard form, which is kind of the last form that we have here. But as a little bit of a reminder, when we first talked about solving in factored form, we did do standard form a little bit. Because the thing is, so if we actually look at page 114 real quick, if I'm in standard form, something like these ones, it's actually best to try to factor, because then it is so easy to solve after that. Remember, we just set each parenthesis equal to 0 and solve two little baby equations. And so kind of, if we can do that, that's what we should try first. So when we talk about today, solving in standard form on page 120 and 121, we are really doing that because it is our only option. Like I tried to factor and it just won't factor. This is sort of our last resort, okay? So I think what I actually want to do is for today, we're going to just fill in our solving in standard form page on 121, and then we'll do 120 in a different video. So when we're solving in standard form, we will know that we're in standard form because there will be no parentheses. And again, I do want to make this little note here. Try to factor first, but if you can't, then we got to do this, which is straight up just a formula. So kind of like when we tell you that the formula for finding area of a rectangle is base times height, the way that we find the X-intercepts or the X solutions in standard form is by using this crazy equation right here, okay? So sort of the way that I say it is negative b plus or minus the square root of b squared minus 4ac all over 2a. So it's a big old formula to remember. I also want to remind you guys that when we are in standard form, that's where the a, b, and c comes from. So a is sort of the first number here, just the number, not the letter. And so wherever we see a in our formula, we will replace it with that number. It's on the x squared. B is always on the x, and so whatever number is on the x, not the x itself, just the number, we will replace that number with b. And then finally, the last number that is all by itself, not on an x, that number is c. And so wherever I see c, we'll replace it with that number. Once you replace everything, then we just need to follow good order of operations to simplify this massive equation as far as we can. And sort of the order that we need to go in is we need to start under the root. And underneath the root, because like low-key in the root, you kind of have parentheses. We don't really need to put them there, but they are sort of there. So that's why we start under the root. And we first need to do the exponent. So square the b. Then over here, we have to sort of multiply these three numbers. So then we multiply. Oh my gosh, that's one too many humps. I multiply the c times the a times really a negative 4. because really the sign in front of it goes with it. And so then whatever I get there, like if I multiply and get a positive number, then I'm going to add. If I multiply and get a negative number, then I'm going to subtract. Okay, so after that, we need to then add or subtract with b squared. And then you'll have solved everything under the root. Then you need to take the square root of that number. So I do all this stuff underneath, and let's say I end up with 4. I take the square root of 4, which is 2. And then we need to add and subtract that with negative b. So take the square root. Then do negative b plus or minus that number. Oh my goodness, I ran out of room. Then divide by 2 times whatever a is. And so we kind of have to multiply before we divide that, but we kind of ran out of space a little bit. Now, keep in mind the big picture here. The big picture here is that we're trying to find the x-intercepts. And when I'm looking at a parabola, sometimes I will have 2 solutions, so 2 x-intercepts. Sometimes I will only have 1, and sometimes I will have none. And so we want to try examples of each of those. So let's try the one that is 2 solutions, because that's kind of most straightforward. So looking at these ones here, we could totally try to factor those. And I feel like on the first one, it would not go so well. And so we'd have to use our quadratic formula, which is what that is called. I didn't even say it. Let's write that at the top. Oh my word. Quadratic formula. It's kind of like an area formula, but for quadratics. Oh my word. So let's just use our quadratic formula here so that we can get a good practice in. So maybe what I would recommend is finding our a, b, and c value. We also have to be equal to 0, so that's a good thing. Looking at this problem here, a is in front of x squared, which is a 1. B is on x, so that's a 7. And then c is not on any letter, so -6. Always take the sign in front. And then, guys, I want to go over here and plug everything in because we are going to need a lot of space. So my equation is x equals -b, so -7, plus or minus the square root of b squared, so 7 squared, minus 4 times the a value, which is 1, times the c value, which is -6, all over 2 times a, which was 1. Okay? So once we fill everything in, then we need to start under the root, and we need to square the b. So when I write this out, that 7 squared is now 49. I can also sort of multiply over here, which we're multiplying a -4 times a 1 times a -6. And so a negative times a negative makes this a positive, so really a plus sign now. And the 1 kind of doesn't matter because 1 times anything is still that thing. So really I'm just doing 4 times 6 for 24. All over 2 times 1. Although low-key, you could just do 2 times 1 right now. That's 2. Okay? Then I need to add or subtract that with my b squared. So maybe going over here now, we'll have x equals -7 plus or minus the square root of the 49 plus the 24, which is 73, all over 2. Next, I need to take the square root. Now, here's where things can go really well or really badly. So I cannot take the square root of 73. Like if I did it on my calculator, it would be a really nasty decimal. I think it's like almost 9, because like 81. But because I can't take the square root of it, I kind of can't do the rest of this. So it's like a good or a bad thing. Like you don't have to do more math. This is just your answer, but also that feels like a really weird looking answer. But it kind of is just your answer. And there are two of them because one of them is negative 7 plus the square root of 73 all over 2. And the other one is the negative 7 minus the square root of 73 all over 2. So I do have two answers. They're just really scary looking ones. Yuck. But again, it's kind of like that thing where I couldn't find exactly where my x-intercepts were. And so this is the exact answer, but the approximate one is a really nasty decimal. So let's try out another one. Okay, so I have to be in standard form equal to 0. And we could try to factor, but let's just use our quadratic formula. So we want to identify A, B, and C. A is 1, B is 7, C is 12. And then we want to plug it into our quadratic formula. So we'll have x equals negative b plus or minus the square root of b squared minus 4 times the a, which is 1, times the c, which is 12, all over 2 times a, which was 1. Okay, so we need to start under the root, and underneath that square root, I need to square stuff first. So we'll have x equals negative 7 plus or minus the square root of 49. And then I can go over here and multiply, and if I think about positive and negatives first, when I multiply these three numbers, it's still going to be negative, so still subtraction. The 1 sort of doesn't matter because when I multiply anything by 1, it will stay the same. So really we're just doing 4 times 12 for 48. All over, 2 times 1 again. That's like Loki, just 2. We can make it 2 right now. Okay, so now I'm still under the square root because there's still more things I can do under there, and we're going to subtract. So 49 minus 48 is 1. And now I think I can continue because unlike the last one, I couldn't take the square root of 73. I can take the square root of 1. The square root of 1 is 1. And so we end up with x equals negative 7 plus or minus 1 over 2. And so now I can sort of keep going. We want to do the negative b plus and minus that top number. Oops, sorry, I'm pointing to it. We want to do that negative b plus or minus the top number and then divide by 2a. So kind of if I think about this, we get two problems. Negative 7 plus 1 over 2. And then negative 7 minus 1 over 2. That's where the plus or minus comes in place. Like one is a plus in between and the other is a minus in between. Which gives me my two answers because negative 7 plus 1 is negative 6 divided by 2 is negative 3. And then here negative 7 minus 1 is negative 8 divided by 2 is negative 4. And so I have two actually really nice answers this time. And that's really because if I had thought about factoring this, like what multiplies to 12 and adds to 7, that's 3 and 4. And so I could have put it in factored form and it would have been a lot easier to solve. But I wanted you guys to see how we do it with the quadratic formula. Okay, so both those had two answers. Hopefully I didn't goof this one up like I did in the last one. Let's try one that has only one answer. So looking at this one here, we have to be equal to 0, and we are, so that's good. So we'll find our a, b, and c. A is 1, b is negative 4, c is 4. And then we'll plug it all into our quadratic formula. So x equals negative b, which negative 4 is going to actually be a positive 4. Plus or minus the square root of b squared, so negative 4 squared, minus 4 times a, which is 1, times c, which is 4, all over 2 times a, which is 1. Then we continue. So we're going to start under the root. We're going to square the things. So we have x equals 4 plus or minus the square root of negative 4 squared. Whenever I square something, it is always positive. So 16. Then when I multiply over here, because I have a negative times a negative, or times a positive still, we're going to stay negative, and I can sort of ignore the 1. So 4 times 4 is 16. All over 2 times 1, which is just 2. Okay, still under that square root because there's still more things I can do. 16 minus 16 is 0. And so I can take the square root of 0. It's just 0. So we end up with 4 plus or minus 0 over 2. But if I do, and this is where, like on the last one, I broke it up and made my 2 equations, one with a plus in between and one with a minus in between. But the thing is, if I do 4 plus 0 or 4 minus 0, either way, it's just 4 over 2, which is 2. So I kind of only have one answer here. And so that's sort of like when your vertex boops right off the x-axis. And so guys, I know this seems really overwhelming. I was just thinking about like when I have taught this in the past to my Algebra 1 students, they all hate it a ton. So you will not be the first Algebra 1 students to hate this quadratic formula thing. And they hate it because it's so much work, they feel like. And then it's so funny because when you get to Algebra 2, I think because you have to do harder things, this actually seems easy. So I know it sucks now, but it will get easier. Let's try one more, okay? So I have to be equal to 0, and this one isn't. So we have to do this sneaky thing where we sort of subtract the 5 onto the other side so that 2 things can happen, really, so that I'm in standard form and so that I'm equal to 0. Because like 5 minus 5 is 0. And then we can write these all out in standard form. So we'll have our negative x squared plus 2x minus 5. And again, we could try to factor that, but let's just use our a, b, and c. So a here is negative 1, b here is 2, and c here is negative 5. And we'll plug it into our quadratic formula. So x equals negative b, so negative 2, plus or minus the square root of b squared, which if you do start getting really good at this, like I could maybe do b squared in my head, like 2 squared is 4, minus 4 times a, which is negative 1, times c, which is negative 5, all over 2 times a, which is negative 1. Now, a really common mistake that some people will do is they'll try to subtract here first. You really can't. You have to multiply before you can subtract. So bringing this problem up here, we'll have x equals negative 2 plus or minus our square root of 4. Now, when I multiply all this stuff, we're going to have a negative times a negative times a negative, which is still a negative. The 1 sort of doesn't matter. We already took care of the negative thing. And so I'm really just doing 4 times 5 for 20. All over, really, negative 2. Okay, there's still stuff under the square root to do. So now I'll have x equals negative 2 plus or minus the square root of 4 minus 20, which is negative 16. All over negative 2. And guys, right there, that should be a big red flag for you because you cannot take the square root of a negative. This right here is a big old no-no. Whenever you get square root under a negative like that, that means that there is no solution. No sol. We talked about that in the last one too. All right, guys, so I know that is a lot of work using our lovely quadratic formula. Maybe I have to post a fun little song to help us remember how to memorize that quadratic formula because it is a big old formula, but good luck We'll talk about this more tomorrow too, never fear.